Here we go, our notes for 5.1D. Are writing equations in vertex form. Please make sure you're in a position that is comfortable for you to learn in. Eliminate your distractions, so remove headphones. Don't talk to your peers. Fully focused. Put your phones away. Anything that's going to distract you from being great, you should eliminate it. Okay. So this is going to be page 81 in your handy dandy notebook. Your notes are printed out a little weird. I apologize in advance. I think it is. All right. So we're going to recall two forms of quadratics. So before the break, we talked about two forms of quadratic equations. And we have our standard form and we have our vertex form. In standard form, just by looking at it, it tells us two things. The easiest thing it tells us is C, which is our y-intercept. So whatever C is, that's our y-intercept. So it gives us a point in the graph right away. Okay. The other thing it tells us is our A, what our A is. If A is positive, that lets us know that we're going to have a happy parabola with a minimum vertex. If A is negative, that tells us that we're going to have a sad parabola with a max vertex. And just by looking at it, that's information we can pull from standard. Okay. So then for our, I just have a brain fart. Vertex form. Our vertex form, the A does the same thing. But why this is called vertex is because our H, our K values represent our vertex. Now, if you need a refresher or to go back over some things in your notebook, the refresher would be looking back over notes from 73 and 74. So on pages 73 and 74 in your notebook, you'll have more detailed information about standard and vertex form with examples. All right, today we're going to be using vertex form. So we're going to be using y equals a times x minus h squared plus k. That's what we're using. Okay, so we're going to follow the steps that are written on your paper. What does step 1 tell us to do? Identify the vertex. It says it right there. Identify our vertex. So our vertex here is a minimum vertex. It's a minimum vertex at -2, -1. Do we see where that came from on the graph? That's step 1. What this means is that you now know that h equals -2 and that k equals -1. What does step 2 tell us to do? Choose another point. And when you choose another point, you want to choose either your intercept or small numbered point. So I'm going to choose my y-intercept. My y-intercept is right here at 0, 3. It's an intercept and it's small points. The reason why we do this is because we're going to need an x value and a y value to substitute in order to solve for our a value. So just to recap, the vertex is telling us our h, which equals -2, and our k, which equals -1. By choosing another point, we get values for x. In this case, x equals 0 and y equals 3. Our third step is to plug into the vertex form. So we're going to plug everything into vertex form. So for y, we're plugging in 3. For x, we're plugging in 0. For h, we're plugging in -2. And for k, we're plugging in -1. So this is me plugging in all the values. So looking at what we have so far, are there any questions? All right, so after we plug in, step 4 says we're gonna have to solve for A. Okay, in order to solve for A, we're going to have to use PEMDAS to simplify this. You don't have to rewrite it. You already wrote it once. I don't know why I wrote it twice. But we're going to use PEMDAS. And what does PEMDAS stand for? Parentheses, exponents, multiply or divide, add or subtract, right? So before I do anything, I have to deal with my parentheses. What is 0 minus -2? It's a positive because it's a double negative, and a negative times a negative is a positive. So 0 minus -2 is 0 plus 2, which is, and then we still have the square on the outside. What is 2 squared? 4. So now this can be simplified down to 3 equals 8 times 4 minus 1. And this is just now a 2-step algebra 1 problem. So what are the 2 steps I'm going to have to do in order to get A by itself? I'm going to add 1. Good job. And I'm going to divide by 4. Perfect. So I add 1 to both sides. After adding 1 to both sides, I'm left with 4 equals A times 4. The opposite of multiplying by 4 is to divide by 4. And 4 divided by 4 is 1. So what does A equal? 1. Step 5 is where you write your equation. When you're writing your equation, the only variables you're plugging in are A, H, and K. You cannot plug in for Y and X because those are your independent and dependent variables. They're the ones that are constantly changing. Okay, so we're going to substitute in for what we do. We know that A is 1. We know that H is -2 and that K is -1. The negative became a positive because over here, the form is X minus H, and a negative times a negative makes a positive. Now, as you look at these 5 steps all together, what step do you have questions about, or do you feel like you may struggle on? None? All right, so we're going to go into example 2, which should be on the other side of your paper. I told y'all, I don't know what happened when I printed. So we're going to write the equation of the quadratic function with a vertex at 3, 1 and f -4 equals -13. Okay, it tells us our vertex, right? So step 1, where it says identify the vertex, bam, vertex identified, 3, 1. So we know that H equals 3 and that K equals 1. Then it says choose another point. Well, our other point was given to us. F -4 is written in function notation. And function notation is just a fancy way of writing your ordered pair. So this actually is just -4, -13. So the point that was chosen for us is -4 and -13. So for X, we're going to use -4. And for Y, we're going to use -13. Do I have the 4 variables needed to substitute in and solve for A? I do. So we're going to plug in all that we know. Okay. After we plug in, then we're going to solve for A. At this point, I'm going to pause, give you about 60 to 90 seconds to solve for A. So checking yourself. If you made a mistake, do you see where you may have made it? Yeah. So now we have our A. And again, the only variables we plug in are A, H, and K. Our H and our K. So when we write our function, we have Y equals A -2 divided by 7 times X minus 3, which is our K, then our H plus 1, which is our K. Still with me? All right, our last example. Word problem. Okay. A marine biologist is tracking the activities of a dolphin. The biologist records the following data during the dolphin's most recent jump. The dolphin reached its highest jump of 7 feet after 3 seconds, and after 9 seconds was at 4 feet. Write a quadratic equation to represent this. Okay. So the first thing we do is identify our vertex. Based on what we read, where do you think the vertex is at? Almost. Okay. 7 and 3 are the right numbers, just not in the right order. It should be 3, 7. The reason being is that the highest lets us know that this is our max, right? And our max happens at our vertex. The thing is, when you're talking about time, time is your independent variable. So it's going to be on your x-axis. So this is going to be our seconds, and this is going to be our height. And we know that after 3 seconds, it's at a height of 7. So that's why it goes, did his little trick. That's why our vertex is at 3, 7, not 7, 3. Okay. And then it tells us, so that's our H and our K. And then it says choose another point. Well, they gave us another point, right? It says 9 seconds was at 4 feet. So here I'm at 4 feet after 9 seconds. So at 9, 4. So my second point that I'm going to use is 9, 4. Do I have everything I need to plug in and solve for Y? A, I'm sorry. There we go. So we plug everything in. And again, PEMDAS tells me that I'm going to parentheses and exponents first, right? So 9 minus 3 is 6, and then we're left with the square, and 6 squared is 36. So we get 4 equals A times 36 plus 7. What are my 2 steps to get A by itself? Subtract 7. Perfect. So I subtract 7, and I'm left with -3 equals A times 36. And what's my final step to get A by itself? Divide by 36. And because 3 and 36 have a common factor, I must do what? Reduce. I have my A, I have my H, I have my K. Can I write my equation? I surely can. So I'm going to write my equation, which is Y equals -1/12 times X minus 3 squared plus 7. And again, notice I only plug in my A, my H, and my K so that I can still have my independent and dependent variables. All right, so what we're going to be doing, or what you're going to be working on, is your exit ticket. So you're going to complete the exit ticket within your groups. And once you're done, you're going to turn it into the white class tray box up here, or you can just go ahead and upload on Canvas, whichever one you want. You just have to do one or the other. Okay. Hold on.